This one is a Diophantine equation. That is, you cannot solve this if you go for the systems of equation. You have to count on the fact that the pencils are integers, that you cannot buy or sell half a pencil. I will show you what I mean by that. It's that some 7th graders bought pencil and paid $1.43. That means the price of pencil times some number was 143. So if you think in pennies, in cents, you can say it's 143 cents. So in other words, we're dealing with an integer here. P is an integer, and number of students who bought it is also an integer. And then some of the 36th graders each bought a pencil, and they paid 195 cents. So there was a pencil times some number here. Okay, now the pencil could have cost a penny, and then this would happen. But if the pencil costed say 10 cents, this would not happen. You will never get 143 cents by multiplying it. So what you have to realize is that the price of the pencil is a factor of these two numbers. So let's see what 143 is made of. 143 is made of is 13, right? So it's 11 times 13. Very nice. Both are prime numbers. So either you had actually you can also think of it as a 1 times 143, or you can think of it as 143 times 1. What I mean by that is this could be 11 cents and there were 13 students who bought it, or 13 cents and 11 students bought it, or it was 143 cents and 1 student bought it, or it was 1 cent and 143 students bought it. These are the only possibilities. Okay? And next one would tell us what happened. 195. Let's factor this. So I can divide by 5, right? I don't see it right away what this is factor of. So let's see. 3 is 15, 45, 39. 5 times 9 is 45. So here we go. So this is made of 5 times 39, but I know it's 13 times 3. Aha, 13 was there. So 13 must be the price of the pencil. So I should see this as 13 times 15. That's 195. I still have the possibility that the pencil was a penny, and there were 195 students buying it, but that's not the case because they said some of the 30 6th graders. So at most there are 30, then some of them bought it. So this is not the case. So pencil cannot be a penny. So therefore, this is not the possibility either. Okay, and if it was 143 cents, there's no way you would buy a few and pay 195 cents. So this is not the case either. So because of this condition that they gave here, it narrows it down to this situation here. So how many 6th graders? This is 6th graders, and first one was 7th graders. So these are the numbers of them, and pencil is 13 cents each. So how many more 6th graders than 7th graders bought the pencil? 4 more is the answer. So the answer is 4. This was a difficult question for the 8th graders, and this was a difficult question for those who are not trained for the math competition type of problem, Diophantine type of problems. So don't be discouraged, but once you understand that there can be only integer answers, and that you got to use prime factorizations to approach this, then the answer reveals itself. If you apply the usual systems of equations here, you get quickly stuck because you don't have enough number of equations.